Hello my dear students, this is Akash SD and welcome to the ASD physics classes. So students, I hope so you all are seeing my videos regularly because in those videos you can learn a lot of basic concepts and all, and it will be very helpful for your exams, especially in board exams also and in the competitive exams also, whether you are preparing for the NEET, JEE, NDA exam or whatever. Okay, so students, in today's video what we are going to see, today's video we are going to learn about the Coulomb's law, in which situations Coulomb's law will be valid, what are the positive aspects of the Coulomb's law, what are the negative aspects of the Coulomb's law, and how this Coulomb's law is different from the Newton's law of gravitation that you have studied in a 11th also and somewhat in a 9th also. Okay students, so let's start the video. So first, you know very well Newton's law of gravitation is applicable whenever the two masses are there, and the Coulomb's law is applicable whenever what is present, the charges are present. And as of now, you know about the electron, protons and neutrons, all that. Na? Electron is the negative charge, proton is the positive charge, and neutron is the neutral particle here. Okay, so first our concept regarding mass and charge should be very clear. Okay, so students, we are going to learn first this comparison between electric charge and mass. Okay, so just see it very well students. So see here please, during the electric charge you can see that here, no? This side of the electric charge here, electric charge can be positive, negative or zero, like I told proton, electron and neutron. But mass, the mass is always positive, always positive. Second point, electric charge is always quantized. Quantized means here, this one here, Q equal to Ne. Q equal to Ne. This is called the quantization here. That means the charge on the any body will be integral multiple of one electron's charge. Okay, Q equal to Ne here. Similarly, quantization of mass is not yet established. Okay, next one, third point here please, the charge on a body does not change with the speed. That is called we can tell invariant. The charge is invariant. That means whatever is the speed of the charge, what will happen, its value will not change. Similarly, the mass of body increases with speed here. So here maybe you know one formula is there. See the formula, m equal to m naught square root of 1 minus v by c whole square, where v is the speed of the mass, c is the speed of the light, and m naught is the rest mass. So here what we understood, charge does not depends upon the speed, but the mass depends upon the speed. Okay, next one students here, electric charge is always conserved here. In which kind of system? Isolated system, electric charge is always conserved. Next one, mass is not conserved by itself, as it can be changed into energy and vice versa. And this thing we used to learn in the chapter nuclei. According to the Einstein equation, mass can be converted into energy also according to the formula E equal to mc square, where m will be the mass defect that you will study in a which chapter? You will study in a nuclei chapter here. Okay, so now I hope so your concept regarding electric charge and mass is very clear. Okay, so as you have understood all these things, so now you are ready to understand the Coulomb's law. Okay, so students, so let's go to the Coulomb's law now. So see here please, the Coulomb's law. See please, very easy, very easy. See here, according to this law, force of interaction between two static point charges is directly proportional to the product of the magnitude of two charges and inversely proportional to the square of the distance between them. So here we have to understand all these things one by one. Here we have written two static point charges. So as of now we are learning Coulomb's law from the point of view of two static point charges. Even one charge in rest and one charge in motion also, that time we can apply Coulomb's law, like when the electron is revolving around the nucleus, is it? So in a Bohr model also we use Coulomb's law. So please remember that here no need to be both the charges static. If both the charges are static, the force will be constant. But if one charge in motion, then what will happen that a circular path means the magnitude wise force will be constant. But if the charged particle is moving in a straight line from one place to another place, then the distance will change and the force will become variable. But as of now we are going to learn for the which charges? Two static point charges. Next one, please remember that here, product of the magnitude. Remember that here we have to always take the magnitude and depending upon the magnitude only we will write the formula. Then after that, whether both the charges are what to tell, same nature, opposite nature, depending upon that we will take attractive force or repulsive force direction. Okay, next one piece after that, inversely proportional to the square of the distance. Even that is called inverse square law also. Okay, that we will see somewhat later also. Okay, so see here, dear students, first one we are going to see when medium between charges, when medium between the charges is vacuum, VACWM, no? Vacuum spelling VACWM, vacuum or air. Okay, so see here please, here I have taken the two charges, this is Q1 and this is Q2. Okay, and the distance between the charges I have taken, let's take for example small r. Okay, so as of now you have to understand that one thing, the force will act along the line joining the charges, that is called the concept of which force? The central forces. The central forces are only having this property. So we will connect both the charges by the straight line here. So here one force will be there, that is called F12, force on charge 1 due to 2. Similarly here we will tell F21, force on 2 due to 1, and here these forces will follow Newton's third law of motion also. So please remember that here the magnitude wise both these forces F12, F21, magnitude wise both will be same. Okay, so first we are learning only magnitude. So what we know that here, according to the definition, this force is directly proportional to the product of the magnitude of the charge. That's why I'm writing mod Q1 mod Q2 by inversely proportional to the square of the distance, that means r square here. Okay, so if we remove the proportional sign, what it will come here? This one we are seeing in a vacuum, na? VAC, vacuum. So proportionality constant will be K, so K Q1 Q2 by r square. This is our formula. Okay, now students, after that, see here please, what is the K? The K is called the proportionality constant, or we can tell electrostatic force constant. What is called? This K is called electrostatic force constant. Okay, so let's see here please. Here I will write here where K is, I will just increase somewhat, where K is called what? Electrostatic force constant. Electrostatic force constant. Electrostatic force constant here. Now after that, this K value depends upon the medium, in which medium the charges are placed, and it also depends upon which kind of system of units also we are using here. Okay, so as of now you know very well, if we see the value of K from here, what we can write? FR square by Q1 Q2 here. Okay, so see here please, here first one, see in SI system or in MKS system, see here please, in MKS system what will be there? This value of K, normally we used to tell 1 by 4 pi epsilon naught also. This will be how much here? FR square by Q1 Q2. I am writing F vacuum, I am just writing F. Okay, so see here please, what this will come here? This value, okay, this value is used to be how much here? The value 9 into 10 to the power 9. Okay, and from here Newton meter square. In CGS system, if we write in a CGS system here please, here in CGS system, in CGS system what will be there? See, K equal to, see this one we have used for just for the unit purpose here. Now in CGS system what to write here? See here please, 9 into 10 to the power 9 Newton means how many dynes? Tell me please here. Newton means 10 to the power 5 dyne into here meter square. 1 meter how many centimeter? 10 to the power 2 centimeter whole square. And this charge coulomb in a CGS system, what we write here? 3 into 10 to the power 9 whole square here. Okay students, so when you will simplify this value will come how much here? 1 dyne centimeter square by Coulomb square here. Okay, that means what we have understood in case of MKS system, the proportionality constant value. See here please, the proportionality constant value how much? 9 into 10 power 9 and this unit here. In CGS system, this value of K will be how much here? 19 centimeter square per coulomb square. Now I hope so. Very clear, na? So what I told, the value of K depends upon the nature of the medium, and after that it also depends upon water, it also depends upon the system of units also. Okay, students, so as of now we have seen when both the charges are in where? Vacuum. Now after that what will happen that here, just let me write here, second point here itself, no? Second point here itself, see, second, when medium is completely filled, when medium is completely filled between charges, so see here, please, here again, here charge q1 is there, charge q1, and here students, what is there? Charge q2 is there, and it is separated by distance r. But here what is there? The medium is there, so let me write here the medium. See here, let me write here the medium. Now medium is present everywhere, the medium is there, okay? And this medium is having the relative permittivity epsilon r, or we used to tell dielectric constant also K. Now dielectric constant K, so epsilon r or K, and please make sure that this K is different from this K. This K is the proportionality constant, but this K is the dielectric constant, okay? Please remember that very well here, okay? Even if you wish, I can write here K dash also, no problem here. And please remember that here, for vacuum or air, this value will be vacuum 1. For air, some 1.00 some nearby values are there, and for any other dielectric medium, the value will be K greater than 1, and especially for the conductors, this value of K will be how much? Infinite, okay? So here also, if I write the values of forces here also the forces will act here, see here, this time I will write here this force medium, here also what is there, students? Medium. So this force is given by F medium is equal to, see please, 1 by 4 pi epsilon into Q1 Q2 by R square. What is this epsilon? This epsilon is called permittivity of the medium, okay? And here I will write one more formula, epsilon R, that means relative permittivity is given by permittivity of the medium by permittivity of the free space, epsilon by epsilon naught, okay? So from here, if we write the value here, what it will come here, see please, F medium is equal to 1 by 4 pi epsilon naught epsilon r into Q1 Q2 by R square, okay? I hope so. This is very clear here. This is the formula, okay, students? Now after that, if we go for the next one, please, see here, please, we know that, as of now what we know? We know that F vacuum, what was the formula, see please, 1 by 4 pi epsilon naught Q1 Q2 by R square, and F medium was how much? F medium came how much? 1 by 4 pi epsilon naught epsilon R Q1 Q2 by R square, is it? So if we divide both of them, so after dividing, what we'll get here? Please remember that here this epsilon R value will be what here? F vacuum by F medium, okay? Please remember that here, if force in vacuum is known, force in medium is known, then we can get the value of epsilon R also, okay? And please remember that this epsilon R value for vacuum, how much? 1, especially for any other dielectric medium greater than 1, and for conductors this value will be how much? Infinite here, okay? So all these things you should remember that here, okay, students? After that, if I talk about one more concept, is there effective distance. Which distance is there? Effective distance. Now this concept is needed to understand the next force. Now so here this effective distance. Effective distance means what? Whenever the charges are placed in a medium, let's take here for example here the charges, this Q1 and this Q2, the charges are placed where? The charges are placed in a medium here. Now let's take here this distance R, and what is present? The medium is present here, the medium is present here, this medium is present, okay? Now effective distance means by keeping the force constant, what should be the distance between the charges in vacuum, okay? So let's take here this distance, what here? This distance I have taken R dash, and here which medium is there? Vacuum is there. So effective distance means this r dash is called which distance? Effective distance here. Okay, so effective distance. But the thing should be what? The forces should be same. So see here please, if here what is there? This is F medium. Here also what is present, students? F medium. But here in this situation, F vacuum, and in this situation what is there? F vacuum. So for this effective distance, both the forces we have to make what? Both the forces we have to make equal for the effective distance. So see here please, here F medium is equal to F vacuum. Now, so see here please, here F medium how much here? See please, 1 by 4 pi epsilon naught epsilon r q1 q2 by r square. And F vacuum how much here? 1 by 4 pi epsilon naught q1 q2 by r dash square. Okay, so when you will simplify this and all, it will come here r dash is equal to r root epsilon r, or we can tell r dash equal to r root k. And what is this k? This k is the dielectric constant. Now before that I have written k dash na, so k dash, is it? So this concept we will use when? This concept we will use when the medium between the charges are not completely filled, the partially filled is there, na? Partial filled here. Now, so just let me see it, partial filled here. Now I have taken one more and see here please. Just this is the last point here. When medium between charges are partially filled here. Now this question and concept used to come in a competitive exam a lot, partially filled here. Okay, so let's see here please, very easy. Here the charge q1 is there and here charge q2 is there. But the thing is what now? The medium is not complete, the medium is partial here, this one. Let's take here, this thickness is how much? T, and the total distance is how much? R. So now we have to calculate the force. So now what we have to do here, students, here please, here this is q1 and this medium, dielectric constant, let's take k dash is there. This medium we have to convert into the air. Okay, so see here please, here this is q2, q2 here. So see here please, here first one, now the total what is there? Air is there. Now, so see here please, the medium, for the medium means, just let me change the color here. Now just see here please, I will change the color. Now, so medium also we have to convert into the air. So this distance how much please here? I have taught you equivalent effective distance. So this is T, that means here distance will be how much? T root k. And this distance how much? R minus T. Okay, so see here please, here R minus T. Just 1 minute. What is this distance? R minus T. So here what we have done here we have converted this medium part, little bit medium part into air. Now overall what is present here? Now overall it is present here. Okay, so here if we have to write the force here, the force. So what will be the force here? Very easy. F equal to 1 by 4 pi epsilon naught into q1 q2 by, now the distance how much here? See please, R minus T. Now R minus T plus T root k whole square. This formula we have to use when? This formula we have to use for which kind of medium? Partial medium here. This medium will convert into the equivalent air, then we'll use the formula here. Okay, so we have seen how many cases? We have seen the 3 cases. When only air is there or vacuum is there. Second case, when between the charges complete medium is there. And third case, when partial medium is there. And you know very well, whenever the charges are same nature, positive, they will repel, negative, they will repel. One positive, one negative, they will attract. But remember that, especially if one charge is positive and another one is neutral, that time also attraction will be there because of the method of induction phenomena here. Okay, so this thing you have to remember that. That's why whenever we have to test whether the body is having charge or not, so that time repulsion is the sure test of presence of charge on the body. Why? Because attraction can take place between the charged body and the neutral body here. Okay, after that, students, just here please, some limitations are there for this Coulomb's law. See here please, Coulomb's law is not applicable in all situations. It is valid under the following conditions. What are the conditions are there? First one, as I told, at least one of the electric charge must be at rest. Both rest, very nice, at least, but one should be at rest. Second one, the electric charge must be point charge. That is, the extension of charges must be much smaller than the separation between the charges. That's why the point charge concept will be applicable. Next one please, here, the separation between the charges must be greater than the nuclear size. Because for the distances 10 power minus 15 meter, lesser distance, the stronger nuclear force dominates over the electrostatic force. Okay, so please remember these limitations also. Next one, students, see here please, the similarities between the electrostatic and gravitational interactions. So what is there? Both forces follows inverse square law. How can we tell here? Because if I write here the electrostatic force, this is how much here? 1 by 4 pi epsilon naught Q1 Q2 by R square. But if I write here the gravitational force will be how much here? Capital G M1 M2 by R square. So here you can see both the sides inversely proportional to R square. So both the forces follows inverse square law. Next one, both are conservative forces. And next one, what is? The fourth are the central forces is there. Okay, conservative forces, some special points are there that you should know that you have studied in the work energy and power chapter here. Okay, and what are the other forces of conservative forces? Electrostatic force is there. In 11th, what we have learned? Gravitational force is there, that is also conservative force. Okay, speak force is also conservative force now. So please remember that all these things. Next one, students, see here please. Some dissimilarities are there between the electrostatic and the gravitational force. What is the dissimilarities? See the first one, electrostatic interactions may be attractive or repulsive, while gravitational interaction is always attractive. Attractive means when both the charges are opposite nature, and repulsive means when both the charges are same nature here for electrostatic. Next one please, electrostatic interactions depends upon the nature of the medium, while the gravitational interaction do not depend upon the nature of the medium. Is it? Very, very important. Next one please, electrostatic interactions are much stronger than the gravitational interaction. So for that, the 3 point, please remember that here, whenever the two electrons are there, so you know very well the electrons are having the charge also and mass also. See here please here. So for example, for electron, if we write here electron, electrostatic force and gravitational force, so this value is used to come nearly 10 to the power 43. In exams they used to ask. Second one please, if in case there is the electron and proton, so electrostatic force between electron proton and the gravitational force, this value is used to come nearly 10 power 39. Is it? And the last one, please remember that here, if in case this is proton, so electrostatic force between proton and this gravitational force is used to be 10 to the power 36. Okay, so all these values you should remember that here. Okay students, so now we have come to the end of the class. So what are the things we have learned? We have learned about the mass and charge, what are the differences and similarities are there. Then we have learned the Coulomb's law, the 3 cases are there. After that we have seen the limitations of Coulomb's law. After that, similarities and dissimilarities of the Coulomb's law with the Newton's law of gravitation. Okay students, so if in case you have understood this video very well, just kindly comment, share and subscribe to my channel. Thank you so much.